Okay, in this video we're going to talk about properties of functions. There's quite a bit of properties to know, so some of them we've already been through though. Let's get right to it. Definition: let f be a function if f of negative x is equal to f of x for all x, then f is an even function. And if f is symmetric to the y-axis. If f of negative x is equal to negative f of x for all x, then f is an odd function and f is symmetric to the origin. So notice how in both of these you're starting off with f of negative x, and you're just going to compute that and see where the road takes you. Okay, what about symmetry to the x-axis? Why don't we mention functions with that property? It would not be a function, first of all, because any graph that would be symmetric to the x-axis would fail the vertical line test and therefore not a function. For example, suppose that f of x is equal to 5x to the fourth minus 3x squared plus 1. F of negative x equals 5 times negative x to the fourth minus 3 times negative x squared plus 1. Now negative x to the fourth and negative x squared, that's the same as x to the fourth and x to the squared. So I've got 5x to the fourth minus 3x squared plus 1, which is the same function as I was given. So that's equal to f of x. F of negative x equals f of x. And that means I've got an even function. Okay, an even function is always symmetric to the y-axis. Okay? Suppose we have g of x equals x squared minus 4x cubed. So you're always going to start off with f of negative x or g of negative x, and negative x squared minus 4 times negative x cubed, that's the same as x squared plus 4x cubed. And we have a change of sign there on the second term. This is not equal to g of x. So how about negative g of x? Well, negative g of x means I want negative the quantity x squared minus 4x cubed. Okay, well that's going to be negative x squared plus 4x cubed. And yeah, that's still not the same. So it's not equal to g of negative x. I was looking at the wrong expression there. X squared and negative x squared. So this is neither even or odd. There's no symmetry on something that's neither even or odd. Okay. Suppose we have h of x equals 5x cubed minus x. H of negative x equals 5 times negative x cubed minus negative x. That'd be negative 5x cubed plus x, which is not equal to h of x. Okay, negative h of x means negative the whole thing. Negative 5x cubed minus x. Okay, and that's the same as I was given here, which is equal to h of negative x. So because negative h of x and h of negative x are exactly the same function, we have something that's odd, and therefore an odd function is symmetric to the origin. Okay. Suppose that we have f of x equals the absolute value of x. Okay, f of negative x equals the absolute value of negative x. The absolute value of negative x would be the same as the absolute value of negative 1 times the absolute value of x. The absolute value of negative 1 is the same as 1. So I've got 1 times the absolute value of x, which is equal to f of x. Okay, since f of negative x and f of x are the same, we end up getting an even function, and an even function is always symmetric to the y-axis. So in these problems, notice how I'm starting with f of negative x, or h of negative x, g of negative x, and I'm just seeing where that takes me. And if I don't get the same expression, then the next thing is to compute negative h of x or negative g of x, and see if I end up getting h of negative x or g of negative x. Okay. Definition, let's let f be a function on an interval a to b. Then f is increasing on the interval a to b if the slopes of all the tangent lines on a to b are positive numbers, and f is decreasing on a to b if the slopes of all the tangent lines are negative numbers. Now the word tangent is Latin for the word touching. Thus, the word tangent to the curve is a line that touches a curve at a single point, and a tangent line should always have the same direction as the curve at the point of contact. Okay, I'm going to mix in that definition a little bit here in the next example, because the next example is an expression of a situation where you'd want to be using tangent lines, and it's, to me at this point, it's important to know the calculus definition of the term tangent lines. F of x is equal to x cubed minus 4x. So let's see here. Where are we increasing and where are we decreasing? We're going to be increasing for values of x that are less than negative 1 or greater than 1. So take a look here. If I'm less than negative 1 and I draw a tangent line, it's going to have a negative slope on it. Okay? And I do have a function, so I will never have a vertical line. It will be a fairly steep slope, slanted in the negative direction, indicating that I'm increasing on the interval negative infinity to 1 to negative 1, and 1 to infinity. So then I'd be decreasing in the center spot, negative 1 to 1. I'm decreasing means that anywhere that I would draw a tangent line, I'm going to have a negative slope on that line, and so the line is going to be slanted in the negative direction, and that indicates that we're going to be decreasing on that part of the graph. Okay. Now at 1 and negative 1, if I draw a tangent line there, I'm going to have a horizontal line, two horizontal lines. And so a horizontal line has a slope of 0, and that 0 is not a positive or a negative number. So at that single spot, at those two single spots, I'd be constant on that part of the graph. Okay. Definition: an absolute maximum is a point where a function attains its highest value, and a local maximum is a point on a function that is higher than any surrounding points. Okay. Similar definitions would apply to minimums. A local max occurs at the hill of a graph. Local min occurs at the valley of a graph. I'll be using terminology like that. There's a note also: local mins or maxes cannot occur at endpoints. Okay, only between the start and endpoints, if there is start and endpoints. So for example, suppose that f of x is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 15. On the interval negative 2 to 3, including negative 2 and including 3. Well, If x is 0, f of 0 is 15. If x is 1, 3 minus 4 is negative 1, minus 12 is negative 13, plus 15 is 2. Okay, here's 1, 2 on the graph. If x is negative 1, I get 10. If x is 2, I get negative 17. If x is negative 2, I get 47. And if x is 3, I get 42. So where do I have local or absolute extrema? Well, there's an absolute max right here at negative 2, 47. And there's an absolute min at 2, negative 17. That's the absolute highest and lowest points on the interval. Okay, now where do I have local maxes? Well, there's one local max that occurs at the point 0, 15. And remember that local stuff, local mins or maxes, cannot occur at endpoints. So this point here, negative 2, 47, I would not think of that as a local max. Okay, it's an absolute max, but it's not a local max. Negative 1, 10 and 2, negative 17, neither of those points occur at endpoints, and so those would be local mins. This point 342 is not a local max or a local min. It's nothing, since it is an endpoint, but it's not the highest or lowest point on the graph. Okay. There's an example, problem 90, page 90. Let's see here. We got problem 14, and here's the curve that we're given. Trying to make all this fit in there. Is f decreasing on the interval negative 8 to 4? Okay, so negative 8 to 4, to negative 4, excuse me. Well, no, so decreasing means that the line would be slanted in the negative direction. It's slanted in the positive direction everywhere. And so problem 16 is f decreasing on the interval 2 to 5. Okay, so 2 to 5. Yeah, so if I draw a tangent line, it would have a negative slope on it. And a negative slope means that you're decreasing. As long as you scan the graph from left to right, so we would be decreasing there. Okay. Problem 18. List the intervals on which f is decreasing. Okay, so where are we going to be drawing tangent lines that are going to be in negative slopes? Well, it looks like from here to negative 10 to 8. Okay, if I draw a tangent line anywhere, I have a negative slope to it. From negative 2 to 0, I have a negative slope. And from 2 to 5. Okay. Problem 20, is there a local max at 5? If yes, what is it? Well, let's see, at 5, no, there's a local min right here at 5, 0, which is not a local max. Okay. 22. List the numbers at which f has a local minimum, and what are the local minimum values? Okay, so we have a local minimum at -8, 0, and 5. The values would be the y values. Okay, so at -8, -4, 0, 0, 5, 0. So -4, 0, and 0 would be the values. Problem 24. Find the absolute maximum of f on the interval -10 to 7. Okay. Well, -10 to 7. That's on the entire graph there. Here's the local max at f of 2 and 10. Okay, so 10 would be my answer. Okay. Let's take a look at maybe one more here. Find the local min and max for the function 6x cubed minus 12x plus 5 with a graphing utility. Okay, so got my graphing calculator here, and I've already got this entered. By the way, the window, I changed the y max to 20. Okay, so I hit graph, and that's what I'm looking at. If I hit second and then trace, and then either 3 or 4, minimum or maximum, then I use the minimum. Then let's see here. I want to go to a spot where I can see a minimum. So there's a, oops, right bound guess. 0.82, negative 1.53. Yeah. And then a maximum. Okay. So maximum, I go 1 to the left and 1 to the right of the minimum, maximum. I'll make a guess. I don't know what that means. Negative 0.82, 11.53. Yeah. Okay. So we'll stop right there.